Dear friends, thank you to be here once again. We saw in the previous chapter the procedures which, statistically speaking, gives us the best chances of closing the hole and obtaining for the patient the best visual recovery. I would now like to go a little bit into surgical technique and explain a few details of my procedure to you. Please note, I stopped operating in June 2016, which means that I have used the 25 gauge very little, and that I did not even touch the 27 gauge that did not exist at that time. So I'm not going to cover anything that may be incompatible with this instrument format. I'm also not going to talk to you about the inverted flap technique, even though I've talking about it very often and for a long time with my great friend Jerzy Nawroski. But I haven't done enough of it to give you any advice. Generally speaking, the surgical procedure for a standard macular hole is not easier than for a macular edema. It is even a little more complex. So all the requirements for illumination, visualization, and staining of the tissues are therefore even more relevant for the macular hole than in macular edema. I will not repeat them. Those who wish to review them can refer to the surgical chapters on edema. Just a word on macular hole in eye myopia, which are infinitely more complex to operate on due to the low contrast after staining, the fineness and the adhesion of the iLem, but also and above all, the very vertical position of the forceps, as if one were working at the bottom of a well, preventing from placing on hands on either sides of the patient's head, and therefore forcing to work in suspension. More than ever in those cases, I recommend that you place only 2 trocars and for lighting use the operating slit lamp of the microscope so that you can use your second hand to stabilize your forceps and avoid tremors linked to this completely unusual positioning. If you don't have an operating slit lamp, you can use the chandeliers at the risk of causing too small vitreous incarceration. So I'm just going to talk about the moments in this macular hole surgery which are different from those in macular edema surgeries. The first moment, which differs a little bit, is the posterior vitrectomy, because for stages 1, 2 and 3, by definition, there is no PVD and it is therefore essential to create it. I have already addressed this problem in edema chapters, but in a quickly way, and I would like to spend more time now. If you are lucky enough to have a machine equipped with an aspiration flow control pump, you will be able to create this very easily and safely by respecting the following tips. First, you need to know some parameters of your machine with, in particular, your maximum infusion flow capacity, which depend on the usual height of the dropper of your bottle if you use the gravity, or the pressure you want to have if you use the IOP system, the internal diameter of the infusion line, and its attachment to the trocar, a high flow system allowing you a much higher infusion flow. You should also know your maximum aspiration flow in water. It is simple. Just check at what flow the vacuum measure at pump level reaches its maximum. For example, minus 600 or minus 650 millimeters of mercury. Second, from there, you will be able to select your maximum aspiration flow you don't want to exceed, which should be lower at all times than the maximum infusion flow to avoid any risk of hypotonia. Third, please note, this implies that you have a different program for each gauge used, since the maximum infusion flow differs according to the gauge. Obvious detail, but it goes better by saying it. You will, of course, leave your maximum vacuum at the maximum capacity of the machine. There is no point in restricting the machine. You may need this aspirating capacity when the hyalurid fibers make an occlusion. Finally, if you want to use the sound aid system that the machine can provide, and that I mentioned to you in the edema, you must connect the sound according to the vacuum level that the machine will use to obtain the requested flow. It is useless to put the sound on the flow that you control with the foot pedal, since by definition you control it. Perhaps reduce your maximum aspiration flow even further, so that in water it does not exceed minus 350 to minus 400 millimeters of mercury. So, when you go from vitreous to BSS, the vacuum will go from minus 600 to minus 350. The sound, which varies according to the vacuum, will be able to change note and thus indicate to you that you are in the BSS. Once these parameters have been set, you will be able to work safer, more efficiently, and faster. After having put in place the trocars, you will introduce your handpiece directly towards the posterior pole, pressing fully on the pedal. Personally, I tried to remove slightly more vitreous in the macular hole than in the edema by widening the vitrectomy a little bit in the central vitreous, just to facilitate the gas injection. You will then work while listening to the sound produced by the machine. You will be careful not to go against the retina. You will remain 3 millimeters from the posterior pole, so as to leave a nice pancake of hyaloid adhering to the retina. The sound connected to the vacuum will rise as the vitreous fills the aspirating pipe to the pump. When the line is filled with the vitreous, the vacuum measured at pump level indicates minus 600 millimeters of mercury. Gradually, you will create a central gap filled with BSS, and this BSS entering the pipe will reduce the viscosity of the aspirating column, and the vacuum measured at pump level will therefore decrease. You will hear a change in sound, and you will know that you are in the BSS. You will then plunge into the adherent vitreous pancake while stopping cutting. The sound will suddenly rise because the hyalurid fibers will enter the door of the handpiece, create a pseudo-occlusion, and cause depression at pump level of minus 600 millimeters of mercury. By simple back and forth movement, you will bring the hyalurid into the central gap that you previously created. Then you will hit the hyalurid and check with a quick tour close to the retina that everything has been removed. You can then remove your handpiece. You have performed your vitrectomy and the creation of the PVD in less than 2 minutes. Why was it so easy? On one hand, because this help given by the sound showed you the variations of the vacuum according to the quantity of vitreous present in the aspiration pipe, an impossible help with the venturi pump since the vacuum is controlled with the pedal. But also, when the hydroid causes an occlusion, the depression in the aspiration pipe can go up to -600 or -650 millimeters of mercury, thus giving you a very high grasping force, but without risk of hypotonia at occlusion breakdown time, as this can be the case if you use a venturi pump. The injection and extraction technique of Kumasi Brian Blue will not differ from those used for edema. As for the ILM peeling, you can either do it as in edema without worrying about the hole, but my preference was to make a spiral rhexis around the hole so as not to exert any traction on the edges of the hole. Then comes the problem of the tamponade, and we will stop there. What are the goals of this injection? First, to close the hole for 4 to 5 days, as seen in the EVS macular hole study. In fact, 2 days are probably sufficient in the small stage 2, but 4 to 5 days are better in a large stage 4, because the surface that the glial proliferation will have to cover will be greater. The goal is to close the hole. It is not to press on the hole. If it was the case, a silicone bubble having a pressure force 10 times lower than that of a hair could not work. No, the goal is simply to plug the hole by offering a plan to the glial cell proliferation. The second goal is not to disturb the patient too much, and this forces us to analyze the problem of the positioning. In a period of confinement, we can already see the difficulty in staying at home, but if, in addition, we have to look at the ground vertically, and a fortiori if you have a problem of cervical osteoarthritis, wow! At the time of the beginning of my career, I personally heard several patients saying to me during the 1 month checkup, I don't know, doctor, if I'm going to heal or not, but the position, never again. These two goals make us immediately exclude the silicone oil, which achieves a less effective tamponade due to its hydrophobia, forces to perform a complete vitrectomy, and of course requires a reoperation. So I know that some operators in Belgium, in Netherlands or elsewhere systematically treat their macular hole with phaco, IOL implantation, complete vitrectomy, 360 laser photogranulation, and silicone oil injection. But then we are talking about maxi-invasive surgery. No, The perfect goal would be to have a 4-day tamponade without positioning, which disappears spontaneously on the 5th day. How much is needed to plug the hole when the patient looks straight ahead in a primary position, for example, while watching television? On an emetropic eye, 2.7 cc is needed. We can therefore have up to 1.3 cc of water without preventing the plugging of the hole. However, these 2.7 cc must remain present for 4 days. How are we going to get this? In order to understand it, we must be aware of the extension and resorption properties of the different gases. Air does not expand. Its rapid reabsorption into the circulating blood gives it a half-life of 1.3 days. It disappears after 5 to 6 days. Despite a complete exchange, after 1 day, the bubble will be less than 2.7 cc and will no longer plug the hole in the primary position. Unless you have made an inverted flap technique, you must therefore exclude it. The volume of a C3F8 bubble is multiplied by 4 in 3 days with a half-life after expansion of 7.5 days and disappearance after 55 to 65 days. We will therefore avoid C3F8. It doesn't make sense to bother the patient for so long when you only need a 4 days tamponade. The volume of a bubble of SF6 is multiplied by 2 or 2.1 after 1 day, 24 hours, with a half-life after expansion of 2.5 days, and a disappearance after 14 to 18 days. The gas, therefore, seems to be the most suitable for our requirements. How to do it? 1.8 cc of pure SF6 can be injected into a phakic emetropic eye without any risk, since the bubble can largely double. However, during the first 10 hours, the time for the bubble to reach 2.7 cc, you will need to ask the patient to lower the head to allow the bubble to plug the hole. The classic technique involves completely filling of the vitreous cavity with a mixture of air and SF6. The problem is that the only free volume available to allow the SF6 expansion will be the volume released in 1 day by the absorption of the injected air. The overall mixture cannot be expansive. This is why the practice is to use only a mixture of 20% SF6. 20% SF6 means 0.8 cc of SF6 and 3.2 cc of air. Half of the air will be absorbed after each 1.3 day period. The SF6 will double in 24 hours, and we will find 0.8 cc's 2.5 days after expansion. The 2.7 cc required to plug the hole will therefore only be maintained for 1.5 days. Some operators take the risk of injecting a mixture with 25% SF6, which allows a tamponade for 2 days in the primary position. But anyway, it remains insufficient, at least for stage 3 and 4. This is why I suggest the following technique. 3 cc's of a 50% SF6 mixture are injected into a phakic hemetracheal eye, 3.3 into a pseudophakic eye. The hole is therefore immediately plugged since there is more than 2.7 cc's, but this leaves 1 cc of BSS available to allow the expansion of SF6. In fact, the absorption of BSS is faster than the expansion of gas. 1.5 cc of SF6 is almost double that is injected in the conventional technique. The air will resorb as seen previously. The SF6 will double in one day. When there is only 0.8 cc's of air, the mixture then reaching a maximum of 3.8 cc. The 2.7 cc necessary for plugging the hole will be maintained for 3 days, almost twice as the obtained in the conventional technique. So you're going to tell me 3 days is not enough for big stage 4 holes. This is true. And when it was the case, I was cheating a bit, asking the accompanying person to remove the TV from the TV stand and place it on the floor so that the patient would have to lower his eyes a little bit, which prolongs the tamponade by a little bit more than 1 day. But the second big advantage of this technique is its simplicity. A 5 cc syringe is filled with pure SF6. 2 cc's of SF6 are mixed with 2 cc's of air before a 30 gauge needle is attached. A 25 gauge needle, the orange one, 17 millimeters long, enter the eye, targeting the macula. When the BSS appears, the injection begins. It will stop when gas bubbles appear on the orange needle. This is to say, in practice, when 3 cc's in phakic eye and 3.3 cc in pseudophakic eye have been injected. This procedure will have lasted less than a minute. No need to prescribe drugs to the patient for IOP problems, neither tablets nor eye drops. I never had ocular hypertonia with this technique. Here then, my dear friends, a little advice I wanted to give you. I could add others like how to avoid injecting under pressure, or how to avoid that the vitreous is incarcerated in the 25 gauge needle. But I'm afraid you will get tired of it. Please send me comments if things remain unclear. Please send me encouragement if you think I should continue chapters, for example, on vitrectomy or strategy in retinal detachment. See you soon, then maybe take good care of yourself.